Hello guys, welcome to Math Vantage. So in this video we are going to talk about the mutual exclusive, the complementary, the dependent and the independent events, and also how do we calculate the probability of not A or the probability of not A or B. And I'm also going to share some hints and the things that you need to be aware of in this type of the subtopics, right? So now we can start. So what I'm going to do, we're going to solve all these questions. You can see that we have four questions here. It's 1, 2, 3, and 4, right? So we're going to solve all those questions while explaining all those terminologies of the mutual exclusive, the complementary, independent, and the dependent events, right? So the first thing that you need to know, or that first thing that you need to write before you can solve this type of questions of probability, the first thing that you need to write is this formula, the additional rule formula, right? Which is the probability of A or B is equals to the probability of A plus probability of B minus the probability of A and B, right? And remember that now, mostly from the previous question papers, the examiners were using or, and, right? So you must be aware of sometimes the examiner might bring something like this, so must be aware of, which is like u, and then here it's n, right? So whenever you see the probability of a u b is equals to the probability of a plus probability of b minus the probability of a and b, is the same thing as u represent or, and then n represent n, right? So you must be aware of this kind of things, because I think in the upcoming the exams, the examiners are going to use these symbols, so you must be aware of. So this is the formula that you need to be aware of and able to be to master it and write it. So after knowing this formula, now let's try to solve these questions. So the first question says given the probability of A, which is 0.6, probability of B is 0.3, probability of A or B is equals to 0.8, right? So the first question is, are the events A and B mutually exclusive? So how do you see that the two events are they are mutually exclusive? The first thing to prove that the two events are mutually exclusive, if the probability of A, check the second dot here, if the probability of A and B are mutually exclusive, therefore the probability of A and B is equals to 0, right? So meaning whenever the probability of A and B is equals to 0, therefore we can conclude that those two events, they are mutually exclusive, right? And the other thing is that when the probability of A or B, which is this one, the probability of A or B is equals to the probability of A plus probability of B. So meaning whenever the probability of A or B is equals to the probability of A plus the probability of B, therefore we can conclude that those two events, they are mutually exclusive. So it means we have two options to solve for the mutual exclusive, right? So now, before we can solve it, now we're going to check what are we given in this statement of ours, so that we can choose whether we're going to use this one of the probability of A and B is equals to 0, or this one of the probability of A or B is equals to the probability of A plus probability of B. So therefore, we can see that we're given the probability of A, the probability of B, and also the probability of A or B. So meaning we can use this second one here to prove that those two events are mutually exclusive. So meaning the first thing that you're going to write is to write that formula, whereby you're going to say the probability of A or B is equals to the probability of A plus the probability of B. This formula is for mutually exclusive, right? So therefore now we have the probability of A or B, right? So now let's find the probability of A plus B. So therefore the probability of A plus the probability of B is equals to the probability of A 0.6 plus 0.3, right? which is going to give us 0.9, right? So after giving us these values, we're going to plug them from the the formula that we wrote, whereby we know the probability of A or B is given by what? By 0.8, right? Whereby is equals to the probability of A plus B is given by what? By 0.9. Therefore, we can see that these two events, they are not equal. The probability of A or B is not equals to the probability of A plus B. Therefore, we're going to use these terms, right? You are just going to cancel. I'll represent a line from that equals to show that the probability of A and B is not equals to the probability of A plus the probability of B. Therefore, we're just going to conclude that the probability of A or B is not equals to the probability of A plus the probability of B, right? Therefore, they are not mutually exclusive. Therefore, you'll just write, therefore, they are not mutually exclusive. Okay, not mutual exclusive, are not mutual exclusive, right? Therefore, we are done with the first one. So you see how we solve the question for mutual exclusive, right? So the other thing that you need to be aware of, sometimes you may be given, but then we'll talk about it after, whereby you'll be told that these two events are mutually exclusive. So solve this type of equations. We'll talk about it later. So now let's continue. Calculate the probability of A and B. So how do we calculate the probability of A and B? Like I said in the when I started this lesson, that you must be able to write this additional rule. So according to our additional rule, we know that the probability of A or B is equals to the probability of A plus the probability of B minus the probability of A and B, right? We are given the probability of A or B, and we have probability of A and the probability of B. Then we can calculate the probability of A and B. The probability of A or B, it's given by what? It's given by 0.8. Therefore, we're going to have 0.8 is equals to the probability of A, 0.6 plus 0.3 minus the probability of A and A and B. Then now we're going to solve for the unknown, which is the probability of A and B. So if we add 0.6 and 0.3, we're going to get 0.9. Then we transpose, we're going to have 0.8 minus 0.9, which is equals to minus the probability of A and B, right? Therefore, now the answer is going to be the probability of A and B is going to give us 0.1, because remember 0.8 minus 0.9 is going to give us negative 0.1. Therefore, we're going to divide everything by negative. As you can see that here we have negative. So the final answer is going to be 0.1. Therefore, now we are done solving the second question. Now we are going to solve the third question, right? So let me just erase here before we can continue. Okay, so now let's talk about are events A and B independent? So how do you see that the two events that are independent? The two events that are independent if the probability of A plus the probability of B is equals to 1. So if the probability of A and B is equals to 1, therefore we can conclude that those two events, they are what? Independent. So we know the probability of A, right? What is the probability of A? The probability of A is given by 0.6 plus what is the probability of B? It's given by 0.3, which is going to give us 0.9. So therefore we can see that it's not equals to 1. Therefore we can conclude that the probability the event A and event B are not what they are not independent, right? Because when we add them we don't get what? 1, right? Therefore we are done with number 3. This is how we solve for number 3. So now we come to question number 4. which is calculate the probability of node A. So how do we solve this problem of like calculating the probability of node A? Sometimes this question can be written as the probability of. So whenever you see something like exponent of 1, just know that it means node, right? So these are the things that you, let me just write few of them. You can be given how to calculate the probability of node A, right? How to calculate the probability of A not B, right? Calculate the probability of B, right? Calculate the probability of A or B not B, right? The probability of A and B not B, right? So whenever you see calculate the probability of not A, remember that I said this like it's like an exponent when it represents not in the probability. So when you see the probability of not A, just know that it's 1 minus that probability. The probability of A not B, so it means it's the probability of A. Therefore, right, therefore we're going to minus with the probability of A and B, right? And then the probability of not B, obviously it's going to be 1 minus the probability of B. The probability of A not B is equals to be 1 minus the probability of A or B, right? And the probability of not A or not B is the same as the probability of. So these are the some of the things that you need to be aware of, right? So if you know this, it will be simple for you to solve this type of questions. So let me just erase here so that we can continue because I don't have space here. So as we saw the few formulas that you need to know. So now let's calculate the probability of node A. So number 4. How do we calculate the probability of node A? The probability of node A is given by what? 1 minus the probability of A, right? Therefore, we're going to have 1 minus what is the probability of A? The probability of A is given by 0.6, right? Therefore, 1 minus 0.6 is going to be 0.4, right? So this is how you solve the probability of node A, the probability of node B. So we talked about everything about the mutual exclusive complementary independent events and also the probability of node A on B. So now the hints, the things that you need to be aware of, right? So now let's see, sometimes the question can come. So if the question comes like, okay, the two events, like let's say, okay, they say two events are mutual and mutual exclusive, right? Therefore, therefore find find the probability of A. Find the probability of A given that given that given that the probability of B is equals to 0.4, for instance. So these are the things that you need to be aware. So whenever you hear this word, the mutual exclusive, you remember what? You remember that the mutual exclusive, the probability of A, which is here, the probability of A and B is equals to 0, right? Or the probability of A or B is equals to the probability of A plus the probability of B, right? So now, in simpler terms, you'll be given this type of thing. So let's say this statement of mine, let me write it like this. Sorry for that one. Let me write it clearly so that you can understand it better. Because I can see that it's not even clear. Okay, here's the example. I'm not sure about the values that I used because I just wrote them. So given two events are mutually exclusive, given that the probability of A or B is equals to 0.3, the probability of A is equals to 0.1, find the probability of B. So you might, there is a possibility that you might be given this type of questions whereby they mentioned the mutual exclusive, or they said the two events that are complementary, or the two events that are independent. So whenever you hear those words in your statement, like independent, mutual exclusive, complementary, go to check what is the mutual exclusive. Remember, for mutual exclusive, we know that the probability of A and B is equals to what? Zero, right? So if we know that the probability of A and B is equals to Z, therefore we can calculate the probability of B, because from the additional rule, we have the probability of A or B, we have the probability of A, we are asked to calculate the probability of B, and we know that the probability of A and B is going to be equals to zero because of what? This mutual exclusive, right? These are the type of questions that they might come in the exam. And whenever they say complementary, the two events that are complementary. So let's say you are given the probability of A, which is equals to 0.4, and you are asked to calculate the probability of B, right? And then you are told that the probability of A and B, they are what? They are complementary. So from the formula of complementary, we know that the probability of A and B is equals to 0. So already we have 0.4, and then we're going to calculate the probability of B. Right? Can you see how the examiner might trick you? And whenever they say the two events are independent, you just know that, oh, the probability of A and B is equals to 0. So just just play with those formulas, guys. So it is very important to know the formula of mutual exclusive, complementary, and the independent event. So um, our lesson will end here. So if you find this video useful, kindly subscribe and share it with your friends. I'll really appreciate it a lot. And don't forget to like, guys. Don't forget to like. So thank you. That's it for the today's lesson. If you have any question, you can leave a comment behind.